let's just see the converse of the basic proportionality theorem. So the converse of basic proportionality theorem says that if a line divides the two sides of a triangle in the same ratio, then the line is parallel to the third side. So now we just wanted to prove the converse of the basic proportionality theorem, and we just wanted to prove if the ratios are same, then the line is parallel to the third side. So let us suppose if I am starting the proof of this theorem by just taking a triangle over here. So let us suppose this is the triangle that I am taking. This is the triangle that I am taking as ABC. Let us suppose this is my triangle and I'm calling it as ABC. So let us suppose if I'll write it over here that given a triangle ABC in which we have let us suppose any 2 points over here, in which we have this point and this point. Let us suppose if I'm taking this particular line as this, and I'm calling it as nothing but D and E, in which we have as the theorem says, if a line divides two sides of a triangle in the same ratio. So a triangle ABC in which DE is dividing, in which the line DE is dividing the two sides in the same ratio as AD by DB is equal to AE by EC, in which a triangle ABC in which the line DE is dividing the two sides in the same ratio as this. So this is actually a given condition over here, and we are assuming that DE is actually not parallel to BC. So as per the given condition, we are just taking this particular condition. Let us suppose if I am calling it as 1. So here we are doing a construction, but let us suppose if I'll write it over here, we just wanted to prove that DE is parallel to BC. So let us suppose if I am doing a construction over here, draw DE dash assuming to be parallel to BC. So let us suppose if I am drawing any DE dash over here, let us suppose this is my DE dash. Let us suppose if I am taking this as my DE dash, this is nothing but my DE dash. This is I am taking as E dash, such that I am just constructing it in such a way that I am assuming it to be parallel to BC. I am just taking this DE dash assuming parallel to be BC. Now let's just start the proof for this particular theorem. So first of all, we'll start with the proof. So we can say by construction, we have actually taken that DE dash is parallel to BC. So by BPT, by basic proportionality theorem, we can say that if there exists any particular line intersecting the other two sides in the two distinct points, then that particular point will divide them in the same ratio. So we can say by basic proportionality theorem, if DE dash is parallel to BC, it implies that AD by DB is nothing but is equal to AE dash by E dash C. So by construction, if this thing actually happened, that DE dash is parallel to BC, so by basic proportionality theorem, AD by DB is nothing but is equal to AE dash by E dash C. So let us suppose if I am calling this as equation number 2. So what can we say from the equation number 1 and from the equation number 2? So we can say from the equation number 1 and 2, we can say that AD by DB is equal to AE by EC, which is also coming equal to be AE dash by E dash C. So this thing actually coming out from the equation number 1 and from the equation number 2. Now let us suppose if I am just taking these two conditions, it implies AE by EC is equal to AE dash by E dash C. So we have this one. So let us suppose if I am just adding 1 on both sides of this equation. Let us suppose I'm calling this as third, and I'm adding 1, and I'm adding a number 1 in both sides of this equation. So this would be nothing but AE by EC plus 1 is equal to AE dash by E dash C plus 1. Let's just sort it out. This would be nothing but AE plus EC by EC, which is equal to AE dash plus E dash C by E dash C. Now as you can see over here, we have AE plus EC, and we know that AE plus EC is actually nothing but this whole AC, so this would be nothing but AC by EC, and similarly this is again whole AC by E dash C. Now if we'll compare both of these, then you can definitely say that EC is nothing but E dash C, which implies that E and E dash are coinciding with each other. E and E dash are coinciding with each other, and if they are coinciding with each other, it implies that DE is parallel to BC, which implies that DE is parallel to BC, because we have taken DE as nothing but a line which divides the two sides in the same ratio. So that was actually the line DE, which is actually parallel to nothing but the third side, that is nothing but BC. So hence this is nothing but the proof. So hence proved the theorem. This is nothing but the proof of the theorem, which is nothing but called as the converse of the basic proportionality theorem. I hope all the steps related to this theorem is all clear to you.